DSM-4. Most of them would also meet criteria in DSM-5 as well, and comparing them to healthy youth, so non-traumatized healthy youth. Exclusion criteria you can see there. We do allow for comorbidities like anxiety, depression, ADHD. Kids were not on psychiatric medications, though, at the time of the study. For those of you who work with this population, if you didn't allow any comorbidities, you probably would not find any of these kids. So this is really more of the rule than the exception. Here's a description of the sample of kids we've collected so far. We actually have more than this, but as far as the kids that are included in the analyses I'll show you, this is more representative. So approximately 27 kids in each group. They're fairly well matched overall on age, Tanner staging, which is a pubertal stage score. IQs are similar. Down below on the lower left, you can see just how highly comorbid these kids are, how many psychiatric illnesses or diagnoses they have. So depression actually is present in about 2/3 of this sample, anxiety disorders in about 1/3, and ADHD in about 1/3. The trauma types are listed on the lower right, or at least the index trauma type, so the one that we associate most closely with the development of PTSD. And in the majority of these kids, it's an interpersonal violence-related trauma, most commonly sexual abuse. But we do have other trauma types represented here as well, including accidents, as well as traumatic death of a loved one, for example, through suicide. So after we recruited these kids, we did a very thorough clinical assessment. They completed a lot of self-report questionnaires, almost ad nauseum. We put them in the MRI scanner, and we had them do 2 different emotion regulation tasks. In the first, we showed them a standardized set of threat versus compared to neutral pictures. We didn't use anything gory or with blood in it, so we tried to be sensitive to these kids. We didn't want to overdo it. And in the other task, we had them look at emotional faces. But these were emotional faces that were changing. These are actually movie clips of faces changing from a neutral to an emotional expression, such as angry, shown in the top right there. We also have a happy condition that's very similar. The comparison condition or control condition for this task is a shape trial, where the shape itself is also has an overall similar shape characteristic to the face, but has an inner oval that morphs to mimic the movement characteristics that we might see in the emotional face condition. What are these colors over the shapes, your faces, you may ask? Well, the kids, we didn't ask them to focus on the shape or the faces. We actually asked them to identify the flash of color. And so this is a test of emotional cognitive conflict and to see how presence of these distractors may be affecting processing in these circuits. So let's start with the emotional pictures task. A little bit surprising to us, we didn't see any overall activation differences in the amygdala. And this is, much of this work was done by my graduate student, Rick Wolf. And Victor had, I know, found in one of his previous studies in response to faces, which we'll get to in a little bit, that there is indeed some amygdala hyperactivation in kids with PTSD. We don't happen to see it in this particular task. But what we did find was hyperactivation in the dorsal anterior cingulate when looking at threat compared to neutral pictures. And here showing that kids with PTSD hyperactivate the dorsal ACC. Again, this fear-promoting area of the prefrontal cortex compared to healthy kids. Interestingly, and we'll come back to this, there was no symptom relationship that we could find with this particular group difference. So we didn't see amygdala activation differences, but we do see dorsal ACC activation difference. What about functional connectivity? So what we did next was to look at coupling or connectivity between the amygdala and the prefrontal cortex. And here, what we found is that kids with PTSD have weaker coupling between the amygdala and these more dorsomedial areas of the prefrontal cortex, these CEO-type regulatory areas, when looking at threat compared to neutral images. Furthermore, we found that the weaker this coupling was, the more symptomatic these kids are. They have greater PTSD symptoms overall, and specifically, they have greater avoidance symptoms, suggesting that this particular circuit is involved in regulating emotional responses, and that a weakening of that may be leading to greater symptoms. Now, I talked early on in the introduction about brain development, right? So this is like a snapshot of a moving target. These kids' brains are developing, but one thing we can ask, even though these are cross-sectional data, is do their age-related trajectories differ? So between kids with PTSD versus healthy kids. And indeed, we did find evidence of that as well. And what we found was that kids with PTSD show weaker automatic fear inhibitory connections with age. So here we're looking at functional connectivity during threat versus neutral pictures between the amygdala and the ventromedial prefrontal cortex. And what we see is that kids, the healthy kids, who are the blue dots in the picture there, show age-related increases in connectivity. Our kids with PTSD are doing just the opposite. So they're showing age-related decline in this automatic fear inhibitory connection. Interestingly, at the younger ages, their connectivity actually appears to be greater than the healthy kids. So one possibility here is that there's actually some early compensation that perhaps fades with time and with additional stress exposure. So to summarize the results from this task, what do we see? We have evidence here that childhood trauma may bias fear circuitry towards an enhanced threat response. And again, this could be adaptive. So there aren't any amygdala activation differences, but we do see dorsal ACC hyperactivation. And we also see a developmental or age-related weakening of automatic fear inhibitory connections. However, alterations that might contribute to PTSD could include these CEO regulatory type connections. So we found evidence that a weaker connection here is associated with PTSD and is related to symptom severity. So that was a summary of the emotional pictures. What do we see in our emotional faces task? So again, we don't see any overall activation differences, group differences in activation in the amygdala. And I should point out, by the way, much of this work is done by Taylor Kading, who's also here in the audience. So you can ask him more questions about it later if anything's unclear. So we don't see amygdala hyperactivation overall in this task either. But interestingly, we do see age-related differences or potential developmental findings, where kids with PTSD are showing sensitization of the amygdala with age to all face types now, angry and happy, compared to shape. Whereas healthy kids, consistent with some of the prior data I showed you, show age-related decreases. Now, here's where it got even more surprising to us. We expected dorsal ACC hyperactivation in kids with PTSD, but we expected it to angry faces, not to happy ones. We saw just the opposite. So our kids with PTSD actually are showing enhanced activation in the fear-promoting dorsal ACC, specifically to happy faces, a condition where healthy kids, shown in blue, are deactivating this area. Furthermore, this has a symptom relationship. So the more kids hyperactivated the dorsal ACC to happy faces, the higher their social aversion and hyperarousal scores were. We then went on to look at connectivity of the amygdala. And this gets a bit complicated as well, but the short of it is that when looking at this more CEO-type regulatory connection with the amygdala, kids with PTSD are responding to and regulating the amygdala to happy faces, similarly to how healthy kids are angry faces, in order to accomplish this task. Furthermore, the more paradoxical that connectivity is, the more reversed it is from the healthy kids, the more symptoms that they have, here shown hyperarousal symptoms. So just to summarize the emotional faces, we've shown evidence here that childhood trauma may bias this fear circuitry towards an enhanced threat response. through developmental sensitization of amygdala activation. We also see that there's paradoxical fear network activation to emotional faces, happy versus angry, that may underlie actually impaired discrimination between what's safe and what's threatening in your environment. So coming back to the adaptive versus maladaptive, let's just consider this for a moment. Which of the changes that I've talked about today may actually be adaptive? So like other animals, we respond, our brains respond, presumably, to adapt to our environment growing up, whatever it is. And if it's a stressful environment, a threatening environment, then perhaps our brains should change in ways that allow us to detect that threat and to survive. And so when we talk about things like amygdala sensitization, dorsal ACC hyperactivation to typical threats, and weaker amygdala VMPFC coupling, this may allow for more automatic, enhanced detection and fear responses in a dangerous environment. On the other hand, there may be maladaptive changes that can come about as well following trauma, such as hyperactivating the dorsal ACC to normally safe cues, or having weaker coupling between these CEO amygdala connections, both to threat and at rest. And so what really may be happening here is a combination of things. There may be adaptive changes following childhood trauma that allow enhanced threat detection, but what may really determine whether a child eventually adapts or goes on to develop stress-related mental illness, including anxiety, depression, PTSD, is whether these higher-order regulatory circuits can appropriately regulate those responses. So you have this enhanced threat detection system, but what does the rest of the brain then do with that? And that may be a particular area that could be translated in future studies as well. All right, so I think I'm about out of time. I will just summarize here briefly, saying that we're following these kids longitudinally as well. I think that's, Mike mentioned that's an extremely important aspect of this kind of work. Kids are moving targets, and we need to study how their brains develop differently, and also how our treatments may or may not correct some of these changes that we're seeing, which I know Victor is working on ardently as well. Okay, so I will stop there. I do want to acknowledge the folks in my lab. It takes a team effort to pull off this kind of work, and my funding sources and collaborators. And thanks to you guys for your attention.